Okay, listen dear students. The last class already from level 3, 15 bits are over. Now we'll discuss remaining bits from level 3. Okay, see that 16th question. The 16th question what they are asked ma? BCC, body centered cubic crystal. In BCC, that is nearest neighbors, means nearest neighboring atoms. The number of nearest neighboring atoms. Nearest neighbors or neighboring atoms is equal to coordination number is equal to 8. Okay, it is very clear. So body centered cubic crystal coordination number is equal to 8 and packing efficiency, percentage of packing efficiency, that also we are calculated in solid state chapter. Directly we have to remember percentage of packing efficiency in BCC crystal structure is 68%. So at the same way, simple cubic crystal packing efficiency is 52%. Okay, and FCC, face center cubic crystal or HCP, hexagonal closed packing crystal structure, their packing efficiency is 74%. Okay, those additional points also we need to remember. For board examination, packing efficiency calculations for simple cubic crystal, body centered cubic crystal and face centered cubic crystal calculations they are asking from every year. So board examination, the derivation and all we have to do, we have to remember. But in objective exam directly we have to remember their packing efficiency of body centered cubic crystal is 68%. And coordination number or nearest neighboring atoms is equal to 8. The same way, FCC coordination number is 12 and packing efficiency is 74. That additional points also we need to remember. Okay, let's see next 17th question. In face centered cubic arrangement, means FCC arrangement. In FCC arrangement, A atoms and B. A atoms are present at corners. A atoms are present at corners. And one corner is missed. At one corner, A atom is missed. Okay. So according to the total, how many corners are present? 8 corners are present. So how many corners are present? 8 corners. Out of that 8 corners, one atom is missed at one corner. Then only A atoms are present at 7 corners. Only its contribution of atom at corner is equal to 1 by 8. Therefore, number of A atoms is equal to, so out of 8 corners, 7 only present. Then 7 atoms are present and 7 into its contribution is equal to 1 by 8. Then is equal to 7 by 8. Okay. Next, B atoms present at face centers. B atoms present at face centers. So B atoms are present at face centers. How many faces are present? 6 face centers are present. Then the number of B atoms, is equal to 6 into, at face center the atom contribution is equal to 1 by 2 is equal to, then 6 into 1 by 2 is equal to 3. Now the crystal, FCC crystal simplest formula is equal to A is to B is equal to 7 by 8. is to 3 is equal to 7 is to 24. This is the simplest. Therefore, the unit cell formula or crystal formula is equal to A7B24. A7B24. So the correct answer is third option. Okay. Let's see next 18th question. Okay, students, let's see that 18th question what they're asked. At given temperature, how many H2O molecules present in one unit cell? Then in that question, the volume of the unit cell they gave. Volume of unit cell is equals to 132 into 10 to the power of minus 24 centimeter cube, and density also they given. So for this question, what we have to calculate? We have to calculate Z value. We know that density of unit cell is equals to Z into M by A cube into Na. Okay. So this is the formula. In this formula, we have to calculate Z value. We have to calculate a Z value. So for this given D is equals to density, how much they gave me? 0.92. Okay, gram per centimeter cube, and mass M is equal to 18. Water H2O molecule molar weight is equals to 18. Then A is equals to A cube. Directly A cube they given. A cube is equal to 132 into 10 to the power of minus 24 centimeter cube. Volume of the unit cell they given directly. And Na value, we know that Na is equals to approximately 6.02 into 10 to the power of 23. That value we can write 6 into 10 to the power of 23 also, no problem. Now, then what we have to find out? We have to find out Z value. Then Z is equals to, means number of H2O molecules per unit cell, that is equal to Z is equal to density into A cube into Na by M. Then D is equals to, D value is equals to 0.92. A cube value is 132 into 10 to the power of minus 24 into 6 into 10 to the power of 23 is Na value by 18. This is on simplification, means 10 to the power of minus 24. This is plus 23. Then 10 to the power of minus 1 will get, means 0.92 into 132 into 10 to the power of minus 1 into 6 by 18. Okay, so this is nothing but 6 1 6 3 it will cancel. Then 0.92 into 13 into 13 by 3 into 10 is nothing but is nothing but 30. This value is approximately 4.048 is nothing but we consider as 4. See the number of H2O molecules in unit cell. Number of H2O molecules in unit cell. In unit cell is equal to 4. So the answer is fourth option. Okay, students, see in the 18th question, it's very easy, Z value they gave. Okay, so sorry, Z value we need to find out or we need to calculate. Density gave and molecular weight of H2O, we know that. A cube they given, volume of the unit cell. Na value also we know that. Z value we find it out. The Z value is approximately 4.048 is nothing but 4, approximately 4. So 4 water molecules are present in one unit cell. Let's see that next question, 19th question. Is very easy, 19th question. The MX has FCC structure. m plus and x minus is like NaCl, Na plus Cl minus is like NaCl structure. So the edge length A is equals to 7.2 angstroms they give. Okay, then radius of M plus is also is equal to, they gave it is equal to 1.6 angstroms, and find the radius of x minus value we need to find out. So this m plus x minus is like NaCl structure. In that NaCl, 2 into radius of negative ion plus radius of positive ion is equal to edge length. Then 2 into radius of x minus plus radius of m plus, how much they gave? 1.6 they gave. 1.6 is equal to, A value is 7.2 angstrom units. Then 2 into radius of x minus is equal to 7.2 minus 2 into 1.6. Then the radius of x minus is equal to 7.2 minus of 2 into 1.6 by 2. C is nothing but 7.2 minus 1.16 to the 32 means 3.2 by 2 is nothing but 4 by 2 is nothing but 2 angstrom units, or 2.0 angstrom units. Okay, the correct answer is first option. So especially m plus x minus 1 unit positive charge, 1 unit negative charge is present, immediately we have to imagine the structure of NaCl, sodium chloride like structure. In sodium NaCl structure, that edge length is equals to 2 into radius of m plus 2 into radius of negative ion, or x minus. So this is the formula for NaCl like structures, the edge length formula. Okay, that is very important. The same way, 19th question also same concept. Let's see that 19th question. Sorry, 20th question also same concept. The 20th question, a binary solid A plus B minus has NaCl. Rock salt means NaCl. Sodium chloride like structure. If the edge length is 400 picometers, then the radius of cation means A plus, they give 75 picometers. What is the radius of anion? Radius of anion they ask. So in this question, 2 into radius of A plus the radius of B minus is equal to edge length. Okay, then the radius of anion, is nothing but B minus is equals to A minus 2 into radius of cation whole by 2. Then A value is 400 picometers, they gave. 400 minus 2 into the radius of A cation, positive ion is 75 picometers, they gave, by 2 is equal to 400 minus 75 2s are 150 by 2 is nothing but 250 by 2 is nothing but 125 picometers. So the correct answer is second option. The second option is correct, 125 picometers. Okay, students, let's see that 21 question, the next question. So 19th question and 20th question, same models and same concept. Okay, 21. The 21 question, Read the question. A solid has BCC structure, body centered cubic crystal structure. The distance of closest approach, or nothing but nearest neighboring distance between the two atoms, is 1.73 angstroms. The edge length of the unit cell they asked. Okay, in BCC, body centered cubic crystal, the 4R is equals to root 3A. It's very clear. And another important point is, for solving A, another important point what they give closest approach or nearest neighboring distance between two atoms is equals to 2R. Okay, so but we have one relation, 4R is equals to root 3A gave. Therefore 2R value how much they gave? 1.73 angstroms. 1.73 angstrom they gave. But 4R is equals to root 3A, then 2R is equals to root 3A by 2. So this 2R value, we know that 1.73 angstroms you have to substitute. Then 1.73 is equals to root 3 by 2 into A. And root 3 value is, we know that 1.732, or A is equals to 1.73 into 2 by root 3. By root 3 value, this root 3 is nothing but 1.73, it will cancel. Then A is equals to 2 angstrom units. And we know that the values they given in picometers, 1 angstrom is equals to 100 picometers. 1 angstrom, what is the relation between angstrom units and picometers? 1 angstrom is equals to 100 picometers. Then A is equals to 2 into 100 is equals to 200 picometers. Okay, so the correct answer is first one. First option is the correct. Let's see that next 22nd question. Okay, understood ma? 21 question what they're asked. So edge length in BCC, body centered cubic crystal. For that calculation of edge length, what hint they gave? The nearest neighboring distance or closest approach between the two atoms in BCC value they gave, that is 1.73 angstroms. So that angstroms, after that values according to options, the angstrom units we have to convert it into picometers, because 1 angstrom is equal to 100 picometers. We know that relation. Next, let's see that. Next 22nd question. The 22nd question what they're asked, a metal crystallizes as body centered cubic lattice. The edge length of the unit cell is equal to 0.304 nanometers. The molecular mass of the metal is 50.3. Then the density is equal to their ask. So for this case, direct the density of the unit cell D is equals to Z into M by A cube into Na. A cube into Na, Avogadro number. The density we need to calculate. Z for BCC, body centered cubic crystal, is equal to 2, and M is equal to 50.3, and edge length A is equals to 0.304 nanometers. 0.304 nanometers is nothing but nanometers we have to convert into centimeters. Then 1 nanometer is equals to 10 to the power of 0.304 into 10 to the power of minus 7 centimeters. Okay, 10 to the power of minus 7 centimeters. Then A value, we know that Na is equals to 6.02 into 10 to the power of 23. Okay, therefore D is equals to density is equals to 2 into M, molecular weight of atoms present in BCC crystal, that is 50.3. by A value is 0.304 into 10 to the power of minus 7 whole cube. Okay, into 6.02 into 10 to the power of 23. Then we'll get approximately 2 into 50.03 divided by 0.304 is nothing but 0.304 into whole cube 3 times 3 into 3 into 3 like thing, but approximately 27. Then this value is 0.028 will comes approximately into 10 to the power of minus 21 into 6.02 into 10 to the power of 23. Then we'll get approximately this 2 1 3 times it will cancel. Then this value is 50.3 by 0.028 into 3 into 10 square, because this 10 to the power of minus 21 here plus 23 is there. Then 10 square will be present. Then the 10 square is nothing but 2.8 is nothing but 50.3 by 2.8 into 3. On simplification we'll get approximately 5.95 gram per centimeter cube. Gram per mole will comes. The density of the unit cell is equals to 5.95 gram per mole, sorry, gram per centimeter cube, gram per centimeter cube. The correct option is first option. Okay, first option is correct. So in this directly density they are asked. So we know that density formula D is equals to Zm by A cube into Na. So Z value they are not given, but we know very well for BCC Z equal to 2, FCC Z is equal to 4, and simple cubic Z is equal to 1. Molar mass they only given, and A value also they given, and Na value we know that. Then we are calculated density. How much will comes na? The density is equal to 5.95 gram per centimeter cube. Okay. So let's see the next question. 23 question. It's very easy ma. Already this type of model questions we did in first PUC in atomic structure chapter. There only we did. So let's see the 23 question. The given compound is Fe 0.93 O 1.00. Like one oxide, iron oxide they gave. In that this iron, this is the iron is the mixture of iron plus 2 and iron plus 3. Both are present, in which iron plus 3 percentage we need to find out. Percentage of iron plus 3 is equal to how much we need to find out. It is a neutral. This compound is neutral. Okay, then the sum of the oxidation states of all atoms is equal to 0. So 0.93 iron atoms are present, and one oxygen atom is present. Let 0.93 multiplied with 100 and 1 multiplied with 100, that means 93 iron atoms. 93 iron atoms present. This 93 iron atoms. Okay, this 93 iron atoms present in Fe 0.93O. If iron atoms are 93 means 100 oxygen atoms are present. 100 oxygen atoms are present. So this out of okay, listen students. This iron 93 iron atoms in which let X iron atoms are present in Fe plus 3, then automatically 93 minus X iron atoms are present in Fe plus 2 oxidation state. Then the total oxidation state, sum of oxidation states or oxidation numbers of all atoms is equal to 0. Then how many iron atoms are present? X Fe plus 3, then its charge is equal to 3 x into plus 3 plus 93 minus x into plus 2 plus 100 oxygen atoms are present. 100 into minus 2 is equal to 0. Then 3x plus 93 into 2. 93 into 2 value how much ma? 186. 186 minus 2x minus 200 is equal to 0. Then x plus 186 minus 200 is equal to 0. Then x minus 14 is equal to 0. Then x is equal to 14. So how many iron atoms are present? Iron plus 3 atoms, 14 is present. So the number of Fe3 atoms is equal to 14. Then percentage of iron plus 3 is equal to 14 by total iron atoms how many are present? 93 into 100. Then we'll get approximately 15.05 percentage. So the answer is 15. So the 15.05 we are considered as 15. So the same 28th question also same. In the 28th question NiO they gave. So there nickel contains plus 3 and plus 2 ions are present. Find the percentage of nickel plus 3 they asked. So the same method we have to calculate 28th question also. Okay students, let's see the next 24th question. Argon crystallizes in FCC, lattice one atom at each lattice points. If the number of if the unit cell length is 5.31 angstroms at 0 kelvins, the nearest neighboring distance at 0 kelvins. See in FCC, 24th question. In FCC, face-centered cubic crystal, in FCC, 4R is equals to root 2A. Then the nearest neighboring distance they are asked. So the nearest neighboring distance D is equals to 2R is equals to root 2A by 2 is nothing but A by root 2. A by root 2. A value they gave. A value how much they gave? 5.311 and root 2 value 1.414. On simplification we will get 3.756 angstroms. So the correct answer is first option is correct. Let's see 25th question. A crystal of ionic compound B ions present at a close packed lattice and A ions are present at tetrahedral voids. The B atoms are present at CCP, closed cubic packing structure, or FCC, and A ions are present at tetrahedral voids. Okay, the number of B atoms, B is equals to Z is equal to 4, and number of A atoms is equals to 2 into Z, because the tetrahedral voids is nothing but double the number of atoms is equals to 8, 2 into 4. Therefore, A is to B ratio is equals to 8 is to 4 is nothing but 2 is to 1. Therefore, the formula is A to B1 or A to B. So the correct answer is second option. Let's see 28th question is the direct. 26th question, direct theoretical. What is that? Diamond, silicon, and quartz. These are belongs to covalent crystalline solids. Covalent crystalline solids. So the covalent crystalline solids have covalent bond forces. They have covalent bonding forces. Bonding forces present. So the correct option is second one, 26. Okay. Next, 27. Let's see. 27 direct, it is theoretical. The edge lengths of unit cells in terms of radius of the sphere contains FCC. They are asked in FCC, BCC. In FCC, we know that edge length 4r is equals to root 2a. Then root 2a is equals to 4r. Then r is a is equals to edge length. A is equals to 4r by root 2. Then 4 is nothing but 2 into 2, and that 1 2 is nothing but root 2 into root 2 is nothing but 2 root 2 r. So the edge length is in FCC is equals to 2 root 2 r. Next, in BCC, we know that relation root 3a is equals to 4r. Then a is equals to 4r by root 3. And in simple cubic crystal, a is equals to 2r, direct. So the correct answer is first option. 28th question also same like 28th question is same like earlier already we did that 23rd question we did the same 28 also. In the 28 nickel atoms is equals to, let it be 98, then oxygen atoms is equals to 100. Okay, in that nickel X atoms are present in nickel plus 3, and the remaining 98 minus X atoms is equals to nickel plus 2. Then how much percentage of nickel plus 3 is present? Then 3x plus 98 minus x into 2 is equals to 100 into 2. Okay, then is equals to 200. Then 3x minus 2x plus 196. Then x is equals to 4 will comes. Then percentage of nickel plus 3 is equals to 4 by 98 into 100 is equal to approximately 4.08 is nothing but 4%. Okay, the same way 23rd question. Next 29. Let's see the 29th question. And 30th question. Let's see the 29th question. Nebidium crystallizes in BCC. The density they given, the radius of nebidium means R value we need to find out. We know that D is equals to Z into M by A cube into N.